Thanks for having me. I'm Oren Penso. I'm a staff system engineer in the Cloud Native BU in VMware. And I will speak about Service Mesh for the next 35 minutes. I will speak in general about the technology, about the challenges, what is Service Mesh, why Service Mesh. And I will end with a live demo of the platform, like the open source project of Istio. And a little bit about our take, VMware take on Service Mesh. So let's start. First of all, who's implemented any Service Mesh in the organization? Something like that? Heard about Service Mesh? Heard about the technology? Okay, so there's a lot of people that heard about it, but not a lot of people that implemented it. And that's okay. That's something that we are all in right now. That's the phase that pretty much everybody's in right now. Trying to understand if we need to implement the Service Mesh, if it's stable enough, mature enough. So let's go. I won't talk about the application architecture change, because everybody's here because of that. Everybody's here in ContainerDays because of the change of the application. But I will talk a little bit about the benefits of microservices that I know that you know of. But first of all is velocity, you know. The main thing that we want from microservices, and the main thing that we are aiming for is to push to push things into our application, to push the value that we have into our application as fast as we can, to move from development to production and to move in small portion. That's why we've moved into microservices. But it's not just that. It's the elasticity, it's the resiliency, and of course, it's the technology. So we want to use multiple development languages. We want to break the application into smaller pieces that we can handle and push faster. We want to do everything in the fastest way to get the advantage for the business side, because eventually everything is for the business, everything is for the app. And that's awesome, that's great. Let's talk about Netflix. Every picture is a different microservices. Every banner is a different microservices. Let's talk about Amazon. Every bit and byte of the application is a different microservices that you can handle by itself. It's the representation against the network is self-sufficient, is a silo. I don't need to tell you about microservices. You know all about it. But just for me to understand, who's pushing code to the application once in 3 months? Raise the hand. Once in 3 months? Once in a month? Once in a week? Oh, great. Once an hour? Once in 10 minutes? Okay, so just so you know, Amazon is pushing things to development only 11.6 seconds. In any 11.6 seconds, something is pushed into production by Amazon. That's amazing. Just think about the amount of microservices they have, the amount of frictions they have. They are touching simultaneously 10,000 servers, 10,000 containers, and pretty much maximum of 30,000. So it's huge. It's unbelievable, the amount of frictions that we have. Think about just the front end of an application. If you're breaking the front end, the web server, any front-end web server that you are breaking to 70, 80 microservices, just do the duplication of the amount of servers that you have, and just try to imagine the amount of bits and bytes that you have in the network. So that's awesome. And we know why we moved there, because we can do it a lot faster. We can see in Amazon. But there's a lot of challenges that comes with that. That's Amazon. And that's Netflix. That's the way that it's connected in their network. That's a mess, not a mesh. You know? That's almost unmanageable. And we need something to make it right, you know? We need something to take care of it. And that's Service Mesh. Let's talk a little bit about the challenges in a wide aspect. So we have multiple development languages, right? We don't have any, like in the past we had 1, 2, maybe 3, but now each and every part of our development teams want a different language because they have different use cases, they want to leverage different capabilities, so there's a lot of development languages. Every bits and bytes of the application need to connect to another bits and bytes. If we are talking about, let's think about in the old way, the traditional way. Inside the server, we had several processes talking with each other, but it was in the same server. It was on the same CPU, on the same memory cycle. Now it's on the network. We need to think how to connect the dots, how to secure the dots. We have a lot of things to take care of. There's a lot of challenges over there. So that's another thing, how to connect and secure the layer 7, the session layer. Know the microservices, like the performance and tracing of the microservices themselves. Now we have one microservice that with a ripple effect can affect the entire application, but it's one bit on the chain, you know? There's a chain of microservices that are doing something. The front end is being hit by one customer, but there's somewhere along the way that could be something that's affecting everything else. So that's another thing. How do you trace everything? How do you manage everything? When we talk about service mesh, that's not something new. Service mesh, or basically the capabilities of service mesh, have been around for a long time, and there's a lot of open source projects that is part of the service mesh answer. So there's parts of service discovery and resiliency and service mesh, meta services. There's bits of service mesh in the gateway environment, in the telemetry for tracing and telemetry. So there's a lot of open source projects that take care of that. By the way, if one project is jumping out, is the Netflix OSS, because the Netflix OSS has bits and bytes in every aspect of the way. Basically, Netflix OSS is service mesh, but it has disadvantages, and we will talk about it. So what is Istio? And Istio is the service mesh that I want to focus on. It's not the only one in the market, but that's the only one that I want to focus on right now. And Istio is basically an abstraction for the application infrastructure from the application itself. We want to decouple the application infrastructure aspects from the pure code, from the business logic. We want our developers to focus on the business logic and not on the other things that there's around. And that's Istio. So Istio is an open source project, been around since 2017. It was built by IBM, Google, and Lyft. When I talk about the structure of the architecture of the project, different parts have been developed by different companies. So Lyft is more responsible for the data layer. That's Envoy, if you know Envoy. Envoy is part of the Istio. And Istio as the management, the control plane, was mainly contributed by IBM and Google. Just the connection to VMware, we have one of our guys that is developing the VMware Service Mesh product as the 6th contributor for Istio, and there's a close relationship between VMware and the community around Service Mesh and around Kubernetes. So the architecture. Let's start with the data plane. Okay, so the data plane is based on the simple fact that we can inject multiple containers into a pod. And once we can inject another container to a pod, we can decouple the proxy, the application infrastructure aspect, from the main service, from the business logic. So it's based on Envoy proxy. Envoy proxy is a different container that we inject to any pod in our application. And basically, the Envoy proxy is going to take care of any traffic that get out of the pod. So everything will be get out from the proxy and get in from the proxy. That allows us to control the traffic on layer 7. So we can do dynamic service discovery, and we can do layer 7 load balancing, and we can inspect the session and do steering of the traffic itself. We can do shaping of the traffic itself, and I hope that I will have time to show it in a live demo. But basically, eventually, everything is based on the proxy. That's not enough because that's just the data plane, and we need a control plane on top of it. So the control plane on top of that, that's Istio. If we have two services connected to each other, proxy to proxy, everything is between the proxies. We can encrypt the traffic between all proxies, so we can encrypt the traffic inside the mesh, inside the service mesh. But now we need something to control it, and something that will allow us to encrypt everything, and that's the control plane of Istio. So Istio is basically built from 3 components: config, policy, and certs. And the 3 components are responsible for different things. The config, basically configuration of the routing, how the traffic should get out from one service and get in to another. What's the route? What's the configuration of the network itself? Policy, that's basically enforce the access rights on layer 7 aspects. So I can do a lot of, let's call it firewall layer 7 rules, and say that user can get to this service and that user can't get to this service. On a session layer, because I know the session, I can parse the session and understand who's the user that's trying to connect. Certs. Certs is basically the component that is responsible for the root CA, for the digital certificates that with them we can encrypt the mesh, and not just issuing the certs, but also renewing them when they out. So it's basically the root CA for each Istio installation. I haven't told it prior to that, but basically Istio is one-to-one with the cluster. So once you have Kubernetes cluster, you have one Istio. If you have two Kubernetes clusters, you have two installations of Istio and its different meshes. I will talk about federation later, but for now, it's one-to-one. Okay, so now I'm just moving around some use cases or why we're going into the service mesh, why we need the service mesh. So we've talked about multiple languages, development languages, and multiple languages demands multiple client libraries, API client libraries, because each language needs a different API client library. And if let's take Netflix OSS as an example. Netflix OSS was based or focused on Java. It's not now, because now they are expanding for more languages, but basically it was written for Java, and it was leveraging the API client libraries of Java. So if we are taking Netflix OSS as an example, and we have multiple services in the mesh, we can do service discovery, and we can do a lot of things, but now if we want to add a service that is based on Python, or Go, or never mind, any other language, the Netflix OSS needs to be changed fundamentally inside the Netflix OSS to allow it, to support it. And basically, Istio is coming from a different angle. From the same decouple that we have talked about between the business logic and the application infrastructure. So if we are taking the entire capabilities of Netflix OSS and we are decoupling it from the pure code, from the business logic, putting it inside the proxy container, now we don't need to understand which language it is. It doesn't matter. It could be any language because the client libraries is abstracted from the business logic of the code. It will be implemented inside the proxy. And yeah, there's different kinds of client libraries that need to be implemented inside the proxy, but you are doing it once, and you are doing it as an infrastructure. That's the main issue of application infrastructure. You are doing it in abstraction from the pure code, from the business logic. Distributed tracing, as I mentioned before, that's Netflix and OSS. Just try to make sense out of it, you know? You have to understand the path that you are going, the transaction is going on. You need to understand what's going on inside the application, what's going on with events and everything. And that's basically distributed tracing. Here also, we are based on, like, Istio is based on an open source project that I know everybody knows. It's based on Yaeger, but Yaeger itself has different capabilities for different languages. So if I want to implement Yaeger inside the code, I need to be dependent on the application development language that I'm using. And exactly the same abstraction. Once we have any problem in IT, we are just abstracting the problem. So taking Yaeger and implemented Yaeger inside the proxy, implemented Yaeger as a different layer inside the application infrastructure, allows me to be decoupled from the application development code. Traffic splitting. That's basically, I think, that's the most common use case that Istio has. Like how to split the traffic to different directions in Canary update or something else, or rolling update. It doesn't matter. So basically, if I have two services, and I have one service with one pod and one service with 3 pods, the kube proxy will divide the traffic evenly between the pods. If I will have like version 1 for the pod, and now I want to do a version 2, the kube proxy will still keep, you know, like divided equally between the pods. So 25, 25, 25. And if version 2 isn't good enough, 25% of my traffic will go to, you know, nowhere. So Istio is allowing me to divide the traffic in a more sensible way, or in whichever way I want. So I can use the proxy now to say the traffic that get out of service A will get to service B on pod 4 only in 1% of the traffic. And any other traffic will be divided between all others. And I can do it not just in that aspect. I can do it 20/80, I can do 10/90, I can manage whatever percentage that I want of the traffic. And I will show it in the demo. But that's not the only thing. Because Istio is sitting on the layer 7 or the session layer, now I can do another properties on the traffic splitting. So I can say, okay, not just 1% of iPhone users with an application of version 2, or just from a browser from US. So I can do a lot of things, a lot of traffic managing on the application layers level with Istio. And I will do that also in the demo. I hope I have time. Network encryption. So we've talked about like decoupling, breaking the application into frictions. And when the frictions were in the same server talking with the same CPU and memory, we didn't really need to secure the communication between the processes. But now that it's breaking apart and there's a lot of moving parts on the network, we need to think about security as well. The plug and play mode of Istio is just enable encryption. Once you enable encryption, you can basically avoid the man-in-the-middle attacker inside the mesh, because everything will be encrypted between the services. So each service will talk with another service with a digital certificate of its own. And the component that is responsible for that, that's the certs. So the cert will be the one to issue the digital certificate and the one to renew if needed. And that's basically when you install Istio, you can install it with mutual TLS or without. And the installation is so simple that unless you have really good reason not to encrypt, that's the best practice to do it. Okay, so a little bit about the VMware take on that. So basically when we talked about Istio and we talked about the service mesh, we talked about the data plane and the control plane. So we have Envoy from Lyft in the data plane, and we have Istio from IBM and Google as the control plane. But something is missing. The part that is missing is the management plane. If you are anyone in the crowd from networking layer, or from networking background, so the management layer is missing. How do you manage it? How do you configure the mesh? How do you manage it in a GUI, not just in YAMLs, and not just for one cluster, but federated all over the place? So basically, we are trying to bring with the NS6 SM, the ability to discover and the visibility of tracing and monitoring and managing, the control of the traffic, split the traffic and divert the traffic, and the security aspects of encryption and everything on top of Istio. So we are not touching the Istio, it's the same upstream Istio, but we are managing multiple Istio pods. So basically it's just management overlay on top of Istio. It doesn't matter if it's on-prem, off-prem, public cloud, or a hybrid cloud. And the capabilities is not just for service-to-service communication. We are trying to extend, no, we're not trying, we are doing an extension of the scheme in such a way that we can manage not just the service-to-service communication, but also understand the user and the data. And once we will know the user and the data, we can actually connect the dots between the end user and the table on the database. And that allows us to do a better root cause analysis that can allow you to understand what is the real user experience, and if something goes wrong in the middle, what's going on. And that's beside of the fact that we are federating everything together, so you can put an application, front-end application in public cloud, and another part of the application on-prem, if it makes sense. So that's the use cases. Any questions before I move into the demo? Great. So let's go to the demo. No questions? Awesome. Yeah, okay. Okay, so basically I'm connected to a cluster I have in the cloud. And I hope that, first of all, the GAT demos will be with me, and the connection will be good. So if I'm doing just kubectl namespaces, I want to show you the installation of Istio. Yeah, it's a little slow, I'm sorry, but it is what it is. And I will enlarge, because I guess you can't see anything, right? Where's the zoom appearance? Is it okay? More? It's okay? Okay. So if I will do kubectl get pod in Istio systems, just to show you the installation. Who saw Istio before? And I'm just wasting his time? Okay. So that's Istio installation, and basically one of the Istio installation is an ingress gateway, and the ingress gateway is basically the entry point to the mesh. So if I want to know the URL for the Istio gateway, ingress gateway, I can do just a get service. And I will get a lot of output from the services of Istio. One of them will be the ingress gateway. And I have an ingress gateway here. You see Istio, ingress gateway, la 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 la. It's really long because it's part of our public cloud offering, and I got the URL from the external load balancer. So that's basically the URL that I got. And now you can see an application called book info, but the book info is referred by the /product page. So the structure of Istio is not just the ingress gateway, because I can have multiple applications inside the mesh, right? So I need to point out my application, and I need to point out the way to get to my application. So if I will do kubectl get gateway, -n book info, that's the application that I'm referring to. I can see an Istio gateway inside the namespace of, I can see a gateway inside the book info namespace. And if I will do a virtual service, that's basically the actual service that's referring to my application. How do I know what's referring to the application? Describe. Let's do a quick describe. And now I can see that I'm going to, where is it? That's it. I'm going to product page to see my application. Everything's okay? Okay. So the application is built in such a way that I have 3 versions of the application in the front end. One version, you can see here the book reviews. You can see the red stars. So if I will do a refresh, another version will be without the stars, and another version will be with black stars. Okay, that's version 1, 2, and 3. 1 is without stars, 2 is the black ones, 3 are the red ones. And now I want to shift my traffic. I want to shift my traffic only to version 1, so I don't want to see any black stars or red stars. The way to do it is really simple. I just need to change the virtual service and the distribution rules. So if I will go to my YAML, just to show you, I can see shifting 100% for version 1. Let's do a cut for that just to show you the YAML file. Okay, so now I'm just saying to the Networking Istio plugin, go to the virtual service reviews and shift any traffic to version 1. I will do a simple kubectl apply. To version 1. And that's it. I'm changing the virtual service. Now when I'm going to the application itself, I will do a refresh, and I'm seeing only version 1. Okay? That's basically changing the traffic into a specific 100% of the traffic into specific version. But that's not enough. I want to change the way that I'm not just referring to the amount of traffic. I want to do it according to a specific user. Right now, there's no user signing in here. So I will sign in as a user called JSON, but I need to change the traffic accordingly. So I will change the traffic. Let's do another cut. So I'm changing the user JSON, exact user JSON, 100% to version 3. Version 3 is the red stars. Remember? Okay. So I will do the same kubectl apply, shifting JSON. Okay? Now, in that YAML, I'm saying 100% from JSON to version 3. So if I'm not JSON, what am I supposed to get? I'm not supposed to get anything. So if I will do a refresh, not as JSON, I don't have anything. I'm getting sorry, the product page isn't allowed. But if I will do a signing as JSON, now I'm getting only version 3. Okay, so if I will do a refresh, see I'm getting only version 3. And if I want to clean the destination rule applications, I have another YAML just for the cleaning, and now I will get the same kubectl proxy splitting 33% and 34% for their views. So let's do the clean one. Now I'm going to get into the application. I will do refresh, and now I'm getting the same thing again. So basically, that was a quick demo of the capabilities of network splitting and network shaping. If I want to do to see the actual installation on the injection of the Istio container inside the pods, I can just do kubectl get pod inside the namespace of book info. Just a second, sorry about a typo. Okay, so now when I'm seeing the pod of the book info, I can see 2 from 2, you see? In the containers, it's not 1. It's not 1 container in each pod, it's 2. 2 by 2. The reason it's 2 because one of them is the business logic, one of them is the service, and the other one is the proxy. How can I see it inside the pod? I can do a describe. So let's do describe. Let's take the product page, that's the front end. And when I do a describe for the pod, I can actually see the 2 containers. So if I will go up, you can see one of them. One container is the product page itself. See? That's the product page. But there's another one, another container inside the pod, and that's the proxy. So that's the Istio proxy, and that's a lot of parameters that we need to be able to do the things that we've discussed. So now questions. Okay, so I'm done. I want to thank you for being here in this hot. I have to say that I've escaped Israel because of the heat, and I got it here in Hamburg. So I don't know what's going on. But thank you guys. Thank you very much. Just a second.
Thank you that you're being here. So I'm part of the Cloud Native Applications business unit as well. So my name is Christine. So we have the booth over there. So if you want to learn more about our technology and our open source technologies, we are having a roadshow here in Hamburg. We're doing this in 7 cities in autumn. So if you want to be invited, so join our booth, then we need your address, and then you're invited. And we are launching our university as well, Kubernetes University, where we are offering a lot of trainings, free trainings to you, and we invite you to be part of. Thank you.